Hello everyone, today we'll be solving number of flowers in full bloom. The question problem statement is very clear. We have been provided a flowers array. We are having the start and the end I, which denotes the bloom in and the bloom out period of a particular flower. I am having 3 to 7, 9 to 12, 4 to 13. And as depicted in this example, it is quite clear that how the things are going. So person standing at index 2 can see only one flower is living at that moment. A person standing at position 3 can see at the two flowers are living, and similarly 7 and 30, 11 can also see that 2 and 2 flowers are blooming. So the brute force is very simple here, that for each of the people I'm going to basically iterate through the people's array, and I'm going to count the number of intervals in which the flowers can be staying alive. For example, for 2, I'm having only a single range 1 to 6 in which 2 lies, and I can have only one flower living at the moment. For person standing at position 3, I can see 2 intervals 1 to 6 and 3 to 7 are there. For 7, I can see 3 to 7 and 4 to 13 are there, and for index for the person standing at position 11, I can see 9 to 12 and 4 to 13 are the ones, so that the person can see two flowers at that moment which is blooming or which is living. So the brute force is of course not going to pass because the constraint limits are quite high, and for that example we are basically going to create the result array. I'm going to have a start and finish. So basically I am segregating the start and the finish time of the blooming of the flowers, and I'm going to have separate arrays for each of them. In order to apply binary search, here I'm going to sort. Basically the concept here lies here is how many flowers are there at a particular index I for the people is bloomed in minus bloomed out. So I have to count the number of flowers which are bloomed in for a person standing at index I, and I'm going to deduce all the bloomed out flowers. So for example, for the person 7, if I were to only compare it with the first element, I would have said okay, 1 is less than equal to 7, so okay, first range, second range and third range. So in that case my answer would have been 3, but I can see that the flowers are having an exhaust limit also, so that I need to take care of. So basically I'm going to store the difference of in and out in my answer array, and for this I'm going to make you understand why this statement is important. So for Bluemin, I'm going to execute a simple binary search in which I am iterating through the start array which is sorted, and I'm going to see okay, for a particular index I, if it is lying in the range, I want to include as many as flowers moving bloomed. So I'm going to move towards the right side. I'm going to eliminate the left half, and for bloom out I am going to see again that how many flowers are bloomed out. So I'm going to go to right whenever my finish of m is less than equal to p. So finish of m less than equals to p here means that the flower has expired the finish limit. So that's why I'm going to right side to see what is there any more, are there any more flowers which are died. So this statement, if n is equal to 1 means, for example, I am having a person starting at index 2, and let's say the 1 to 6 were to be 2 to 6. So in that case I would have 0 flowers in the array, and in order to avoid putting back that value, like I didn't have any flower at position 1, I'm going to simply check if I was unable to find the bloom in. If I was unable to find the bloom in for the index for the position 1, I'm going to simply continue without pushing back. And this was the whole question, and it has been successfully submitted. Thank you so much. Yeah, thank you.